yeah, hopefully this can be seen well. Actually, oh, what I should do. There you go. Uh-huh. Okay, cool stuff. So, okay, so the first thing in the syllabus is set up the scene, right? Yeah. So GitHub and parse through branches, okay? So, well, actually, oh no, the real, oh, actually, the first one is this one. It's as an array, so it starts from zero. So very, very cute little quirk right there. So you have most of this stuff already, right? So you downloaded Python, you downloaded VS Code, so created access to a GitHub account. That is important. So you know that you can get to your GitHub account, right? Yeah. So you go GitHub. Online. I do want to explore that a little bit. So we all go over this a little bit. So here's your GitHub. You can see things. Oh, look, you follow me. Yeah, that's cute. You fork the repository. It's my repository, but that's cool. Dope. So yeah, you can do that. Top repositories as your own repositories. In here, you can see a bunch of the stuff that you have. The repository is probably obviously what everyone cares about. I haven't even looked to projects does. Like, what is this? So,
yeah, what even is that? Like, do you make your project on GitHub or something?
Spreadsheet, build like spreadsheet, project tables, and canvas or. Oh, yeah, this is like Lucid chart. Oh, yeah, makes sense. I might give that a try at some point. Let's not get too derailed. So yeah, here we have all this stuff. So the one that I want to use for this is this one. Like this one is the one that is like very structured that I want to know like free ball in it. But as you can see here on this one is each of these numbers. So for example, if you get lost, each of these numbers map
To all that.
to like
Oh, is that
each
why
of
you
the
have like
lessons.
the
Yeah, yeah. So
like the
stage
environment
zero,
setup?
yeah, stage zero maps onto this thing, right?
Right.
So I do want to show you a specific thing that I do want you to do because this thing I didn't do the first time.
Right.
So you don't know GitHub desktop, get familiar with GitHub, and then we create a repository. I want you to see this part because this part actually makes because this thing is like so annoying to deal with. But there's a way to deal with it, and I'll show you all about that here in a second. So go to your GitHub desktop. We're gonna create a new repository. I might just delete it here after, but so create new repository. Okay. So do give it a name. Just that I'm gonna name it test rep.
So I make a new repository then?
Yeah, yeah. Follow along with what I'm doing.
Right.
Yeah, I'm gonna just say delete because I'm gonna delete it later. Uh, and the description, this is just to show git ignore. Okay. So
What even is getting ignored? 'Cause I saw it. It's an extension, no?
yeah, no, it's not an extension. It is it's a file that tells GitHub what to ignore. Okay, so there's things that you don't want. For example, like PyCache and like Py modules and things like that. Well, I don't know. Depending on your case, but like usually you wanted to ignore like the modules and things because those are gonna get downloaded no matter what.
Right.
Okay, so
So is that to like free up resources or something?
yes.
Yeah.
Free up resources and where you download your things, so it's easier to download.
Yeah.
Okay.
Alright.
So, for example, here you have this git ignore. So in here I could put Python, and it's gonna give me the default Python git ignore, which is we should have done this from the beginning, 10%. And then I'll make you copy paste the one that you get from here into your actual project. License, most people use MIT. You can use that if you want. It's like clutter unless you're gonna like use this for something like super serious, but whatever. So here you go. So this
Right.
will you create it, right? And then it gives you this git ignore right here. Then here you see all this stuff. This is stuff that like GitHub generates by itself for some reason or another. Like here you have Pyre. Pyre is like I'm not sure actually what Pyre is, but there's one that I might be more familiar with. The Django stuff. Yeah, that's for web stuff. Unit tests and stuff like that. You don't need like you don't need to like keep with your builds. Of course, yeah, the builds. But the one that you want the most is this the PyCache. That's the one that we deal with it, a lot, like the optimized DDL files. Like, yeah. So what will it do? Okay, once these files appear in like they get self-generated into your repo here, GitHub will ignore them and they will not be added into your commits because those get like the more you do those commits, like it just piles up in your code and it's a bunch of useless information that goes against what GitHub is for, right? GitHub is so you can know exactly when you did a change and what you changed. You know, that's very important. Okay, so
It will tell you a bunch of crap, and you have to look for
every change, yeah, every change. For example, the thing that we deal with the most is PyCache. So like those are like some optimization files and some like libraries that get like imported from uh
Pygame.
Pygame, yeah, from Pygame. So those get auto generated there, but those will get auto generated no matter what. Okay, so we don't need to save them in our code because they don't affect our code, right? So they're useless, really, for us. Oh,
Yeah.
they're useless for us to save. Obviously, they're very useful because they like make the game run, but they're useless for us to save in our code, right? So that's why we add them to the get ignore. So what I want you to do now is I want you to copy this thing here, or like I want you to open your actual project. So for example, I'm gonna open my shark class here. I'm gonna copy this guy, repository, open VS Code. So I open it up here, and I have this measly git ignore with nothing on it. I'm gonna delete this.
I like paste
Yeah, I'm gonna just look.
onto the shard class.
Yeah, I'm gonna grab it like that, and I'm gonna put
Yeah.
it like that.
I'm just gonna paste.
Yep, you do that, and you're good. And then I'm gonna delete this other repo, this test repo delete. I'm gonna just the repository and remove it, and also remove to the recycle in the repository because I want it's pretty useless. But if anytime next time that you are creating a new repo, make sure to just fill out that form, even though like yeah, fill out that little form at the top. It takes like 1 second and improves your code by a lot. So it is always worth it to do that. Okay. So I actually follow my own advice on that. I didn't do it last time. So yeah, it's important.
Yeah.
So yeah, create the repository. So commit, what is commit? Okay, so can you tell me what commit is?
I mean, technically speaking, you basically saves the word. Like it saves the word to like the what's called the cloud. I think that's what it does.
Okay, so it saves it. It does not save it into the cloud.
Oh.
Okay, so a commit only saves it into your own computer. Okay,
Oh, right.
there's like a internal data for all the Git repos that is maintained by the internal Git of your computer, right?
Yeah.
And the commit only basically updates all those
Files.
yeah, all those files. Yeah. So that's what commit is for, right?
Yeah.
Publish, that's basically putting it, basically adding a new entry to all of your repositories that are in your cloud, right? But that's like let's say you have a library, it's like adding a new book, okay? Add a new book. And push is like adding a new page, okay?
Wait,
Push is like
do that, like you just make a new.
no, so remember the push is what you say when you say save to the cloud. That's why, for example, let me do one here. So for example, in here, I'm a oh no, this is not it. Shark class. So I'm gonna add here. Uh added correct git ignore. So I'm gonna add that. So look, in here I'm committing.
Yeah.
Okay. So I commit it. Now this is only saved in my computer. Okay. Now if I do push, then that sends it to the cloud. So now that saves it like that. Remember, so now think about what we have here. So for example, you have a book, like commit is you have a book in your desk, okay? A book that you work on your desk. And the library, like your desk, like your cloud library, that's the cloud, okay? So whenever you publish or you whenever you publish, it's like you're adding a new book to that library. That book might not have any pages on it, right? But you said that there's like is the cover of the book, right, in the library. And then when you push, you're adding things to that book, or you actually might be removing them, but you're adding things to the one on the cloud, not the one that is on your desk at the moment. Okay, the commit is basically just putting things on your desk. You those things might be removed before you even control this.
either way.
So okay, so Control S that saves it into the disk, into the files, right?
Right.
But that does not commit them.
Well,
What's the difference on the commit? The commit keeps track of the changes. So in your file disk, okay, those are just files that contain like a specific like program, okay? So that is basically just like the set of instructions, right?
yeah.
Now, the commit keeps track of the changes between the one commit and the next. So basically, you have 0 words on this paper at first, right? So actually, let me I'll put this something on the screen here. So I'm gonna do, how do you call this? This is main dot main dot ends. Okay. All right. So when I exit. Okay, so just a quick visual example, right? So you have this page here, right? This page here and this page here, right?
Yeah.
So I write a couple lines. So in this page, I have nothing, right? And then in this page, I have some stuff, right? And then this page, I deleted all those things, right? So what GitHub keeps track of, right? What GitHub keeps track of is the difference, okay? Is the delta, or is the delta between this and this. It doesn't keep track of the file itself. It keeps track of the changes between one file and the other, okay? That's what a commit is. The commit is the changes between this file and this file, right? So you could say that the information that gets stored, okay, and stored between, let's say, this page and that page, let's say that this page only has 2 lines, okay? So the information that gets stored is, so what your files do, right? What your files do, they just keep track of the page as it is, right? That's your, when you do hit Control S, that's your file system, and that just keeps track of this page right here,
Okay.
right?
Yeah.
What the commit does, it keeps track basically of the data inside. So this has 4 lines on the inside, right? This one keeps track that, you could say that you could say something like this, and this is kind of what GitHub does.
It's just
That
yeah.
the information that it does is that, for example, actually, let me even do it better. This is exactly how GitHub does it. So let me change that up. Do a little quick analogy. Hey man, how you doing? So let me put this up as like 6. Oh boy. So let's not bring that up to you. Let's keep that. Let's keep that somewhere else. Right there, just to make it like a little bit more visual, like that. I might end up using this. Right? So what does GitHub do, right? GitHub keeps track of this, right? So you have 0 things here. Then GitHub keeps track of all these green lines. You just added these green lines, whatever they might be, right?
Yeah.
It doesn't keep track of the document. It keeps track that you have added these lines, right? And then in the when you delete the 2 lines, it keeps track that you deleted these lines, and now basically the outcome is this. So like if you keep track of the whole history of a file, it'll basically give you the end file, but like throughout the process, it will add all the files, then it'll delete some of the files, then it'll add more files after that, then it'll delete them again, and then it'll add them again. You know what I mean?
Yeah.
Because that's what you did. It keeps track of the history of what you did. So, and if you don't commit, important, if you do not do a commit between you adding or removing stuff, right? Then those changes that you did get lost. So why is that useful to us? Is because that way we can keep track of what we added or removed in our program, and something that we added or removed causes a bug and it breaks the program, then we can say, oh, it broke here, so it's because we added this part to the program, right? So that's what GitHub does. Okay, that's what the commit does, right?
But I have a question, right? How would I commit everything? Do I like do it from main or like you know what I mean? Like
So to commit all the
oh
files,
wait, no, oh there's check marks, right? Yeah, there's check marks.
yeah, you can choose just to commit like one part.
Yeah.
Yeah, you can choose, and that's like in like very Like obviously I do some stuff not the best practice. Sometimes like all willy nilly that I just like hit commit on everything and then I say like send it, which you can do at some points. It's best to be like super structured about it. I mean, in all honesty, it depends on the scope of the program that you're doing. Okay, if you're doing some heavy metal stuff for like an organization that requires strict guidelines for stuff, like you should be very strict about I mean you have to, otherwise you get fired, about the way that you structure your commits, because I mean some people like GitHub is the standard, is industry standard, but some people use some other program for whatever reason, but it's basically the same thing, right? So yeah, like someone in industry will ask you to like follow a very strict set of guidelines. So like if you like, some people are like super like fascist about the way they run this stuff. So basically, like you make a change on a bit on a page, you commit it with a description, otherwise we like destroy your code. Okay, so yeah, so and it makes sense, like depending like on what you're doing, like your code could like be the difference between yeah, like your code could be the difference that like something blows up or not, you know. So yeah, and people need to keep track of who did what and like who was in charge of everything, so that like stuff like, because people make mistakes. Okay, it's human to make mistakes. So yeah, so this is trying to like make that not happen as much. So yeah, whatever. So that is to explain what the and pull. Yeah, what pull is just grabbing from the cloud. Whatever it's on the cloud, you pull it, you bring it, right? So you clone, so that, for example, like what you did, you forked a repository, that's cloning from the cloud. Yeah. So install, okay, so command line install pygame, we did that. So that's just like pip install pygame. So I'm not gonna get too much into that. Yeah. So now let's go into the number one. So git her parse through branches, look at how the class is structured into branches, check out look how the class is structured. Oh, this is what I was telling you, that the class here is structured in the branches. So if you get lost, you can just follow this. So yeah. So what is the next part? So next part is this. So let me open up a quick project for this.
Did you make one?
I did make one. So for example, what I could do. Actually, yeah, I should do this. Let's see how this format goes. So we're going from zero right now. So it is called Python Python project. Python 2D game. Yeah. And I'm on stage 6 right now. I'm gonna go to stage 1. Oh, this branch is not published. Some of these branches I haven't published everything, so might not be correct.
So
So
that's like the beginning, right?
yeah, so I'm gonna explain basically to the beginning what happened. So check Pygame website for methods. So yeah, obviously, if you want to go check out the methods, like here you can find all the stuff that like does something. There's an ungodly amount of stuff here, as it should be, because it's a game engine, so like it can do a lot of stuff. So yeah. So, but I mean, what we are mostly using it for is just to display the graphics, right? So,
Well, physics, huh?
well, no, the physics we're doing ourselves,
Right.
right? That's why
Oh,
Pygame we only use for the graphics. Maybe there's even a better library for only graphics. No comments, no nothing. Okay.
But I think it's better practice to like not use the library, right? Or
No. Oh no. Okay, I'm gonna disagree with you. Hardcore. No,
really?
for specific stuff. Okay, because listen, I'm gonna be honest with you. If we start programming the drivers for the graphics, we would still be on that and we would not be finished. Okay.
Yeah, no, that's true.
For example, actually, like when it
Or
depends what you're doing, yeah. So, but like, so I haven't done programming for like the graphics driver to like make it basically to display. It would be pretty boring, and I mean,
I mean, I think it's pretty cool.
I mean, if I could give it a go. I could do something for that at some point. But basically, I mean, but this is what it is. Basically, you have to map out, like you have to. Well, you would have to. Depends how deep you want to go. Like if you want to go all the way to like Linux, like you could go all the way to like electrical engineering, okay?
Yeah.
Because in a way, what is this whole screen is just LEDs that shine in a specific way on every place,
Yeah.
right?
So
It's probably not LED, it's probably something else. But I'm just going by like some intuition there.
I mean, it's
And you
mostly like fixed.
map them all. No, no, map them all, and then do something that like keeps the frame rate and something that changes things based on
Frequency.
well, yeah, and I mean, but like for example, think about it. This is something that you don't even think about in this type of stuff. You would have to program how often you recheck the mouse. Okay, so for example, like what you're asking kind of is how to go from console to go to a GUI.
Yeah.
Okay, because that's kind of what you have. Like your computer, your mouse, the things that you have here do so much stuff. For example, look. So think about this. The whole screen right now is a GUI,
Yeah.
right? So it needs to be redrawn the same way that I showed you, right? That it needs to be redrawn over and over and over again, right? And there's GUIs on top of GUIs, but whatever. But so keep in mind that the computer needs to keep track of where my mouse is and then tell it to be redraw a specific intervals, right? But my mouse is currently sending information that the computer needs to recheck, and it's not only doing that; it's doing like a million other tasks, right? Right? Uh, the mouse, I have to allocate when do I check the mouse. So I have a list of tasks that I have to do, right? So I have to like first check that the processor has not burnt up. Check that the screen is still displaying. Check what the screen is to display. Check if there's been any delta on the mouse position. Okay, now grab all that information, redraw the screen, and then do it all over again. Okay, how and then it's called soft processes. You don't check the mouse every time. You check it every like 100 or 200. Like so like the normal things that the computer does, it does it 100, 300, a lot of times every second, right? The mouse only gets checked like once every fraction of a second, right? So basically, you have to say like only check the mouse every 300 milliseconds or something like that, you know? So
And wouldn't you have to use what's it called, assembly language for all this, or
you can go as deep as you want,
yeah?
right? So that's what I'm saying. This is to learn Python, right?
Yeah.
If we were to learn that, we would not get to Python probably like in a year.
Yeah.
Okay, so we need. Why do we need the library? It's just to get us to the point that we want to go from.
Yeah.
Okay, so we want to use Python, so we'll use this to use Python. Okay.
No, yeah, but I always hear like better program what's like under the hood for like some things.
Depends on the scope of what you want to do. Okay, so depends on what you want to practice. Okay, so if you want to practice C++, then probably yes. If you want to practice like deep deep assembly language, like probably yes, right? You are basically gonna end up like building the libraries yourself. Like depends what you want to practice, right? Uh, but yeah, so like I mean, if what I want to do here is do the physics engines,
Yeah.
right? So I'm not gonna be using like a physics engine like for example, what I could do is get some other thing that already when you press start, like it drops a block and the block already has the physics pre-programmed into it, right? So that's what we're doing right now. We're gonna be basically adding the physics to the block, right? So the cheating part would be to do a library that does that for us. There's probably a library that does that for us, right? What we're doing is we are doing it. Okay. So, and why? Because all of that is on the layer of programming that is within the scope of this, which is Python, right? We are going to do it all on basically more or less vanilla Python. I mean, maybe we'll use another library, but what the library is for is just to do like vector math, like what is it called? PyMath, math pie,
Good for math. I'm
pie.
pretty sure it's not math, no?
No, no, no,
What else? Or like dot vector or something.
no, no, no. It has a name. They use it a lot. I forget the name right now, but we could use something like that. Just just so we don't have to do any of the very long like vector processes ourselves. Because like to do a matrix inversion, like inverting a matrix, is very complex. It's a very complex like like thing.
Yeah.
If you want to study like hardcore math, go for it. But if you want to learn how to program, that's not gonna help you that much. I mean,
Yeah.
I mean, if I guess yes, it will help you. It'll help you show you how to do that, but maybe not so much of this.
Yeah.
But I mean, we could, and I have been doing some stuff like that. But I've been doing a math lab. But yeah,
Oh, you do MATLAB?
yeah.
Yeah.
So
Cool.
no, yeah, no, it's cool. So, but whatever. So we're using the library. So we'll use like whatever things we have here. So if it can help us get to some places faster, we'll use it. Okay. So yeah. Um. So yeah, we just talk about that. So cool, cool, cool. Check website for methods, right? Create main copy paste code, run it, right? So basically, right, we just get the example code. What I say is that you just get the example code from here. I paste it into here, and I just run it, and works. It works. Yeah,
Yeah.
it works. Yeah,
Takes a while.
yeah, yeah. First, it takes a bit because but then like it generates libraries and then it takes lesser every time.
Yeah.
So but yeah, so cool stuff. And because we did the git ignore, those libraries will not be added into our git. So that's good. So moving on, let's go into stage two. Is this polished? Yeah, very nice. So what is a stage two about? So importing assets. Okay, so here we're already doing a bit more programming. Okay, so importing the assets. Let me swap into that. Oh, I'm already stage two. So this goes to how paths work, right? So like how the paths are structured in programming, right? We have a string, and that string describes where to find the file, right? And then you use the slashes to go to signify that you're going inside of something or going out of something, right? Of a folder, of course, a directory.
PNG.
No, the slashes.
String there.
PNG. This is a string.
Yeah.
So what am I doing there, right? So what I'm doing there, let's get a notepad out. So
I also use a notepad for it.
no, it's good. It's good. Yeah, it's not. It's amazing. Actually, I would give like I say never update, but like something good about Windows 11. The Notepad. I like the Notepad. So cool. So all of your files. Okay, so all your files come from the disk. Okay, the C disk, right? So when you open this up, right? You go to this PC,
Yeah.
right? It says C,
Yeah.
right?
The C
So yeah, the C drive. So this is the root of everything, right? So I go here, bada bing, and then I have all this stuff here. So now if you check this out, then I am in C slash, so inside of C. So before, look, if I go back, then it's this PC that is basically like zero. This is point zero, right? Point where there's nothing. Then I'm inside C. Then you can see C dot slash, right? And then let's say I go deeper, users. Then I have slash users now inside of users, and then I go A86. That's my user, and then I users slash E86, right? And if I go back one, if I go forward one, and in there, you can just find all the type of stuff. So for example, if I keep going inside, go documents, Vex projects, no, that's not what I want. I want to go
The
to,
GitHub one.
huh.
Yeah, it's kind of hard to find. It literally just gets lost in an ocean of files.
Well, no, I kind of know where it's gonna be here. So yeah, go to GitHub. There it is, GitHub. Because something that I would criticize is that it comes integrated with the with Drive, which makes things confusing sometimes. But
Yeah.
I mean, it's actually for the better. Whatever. So, but you see now, users A86 GitHub, and then I go, let's say, let me go to the Python 2D class, and I go to assets, and I have the ball here, right? So look at the path that I have right now. Look, this is the path to the ball, okay? If I want to find the ball within the computer, I have to use this path, okay? No other way will work, okay? But what does Python help us with? For example, what does the library help us with? Or like I think this is part of Python. This is like OS path.join,
Yeah.
right? So what path.join does is basically
It
this
looks
is
for the
like it resolves the directory.
specific image.
It resolves the directory. Let's think about what it's doing here. Okay, so path.join. Okay, this will join the paths. So basically, it does a couple of things. But for example, dot dash. Okay, dot dash. This means where you're currently on. So wherever this file is located. Okay, so whatever. So for this example, this file is located here. Okay, it's located on. This is the location of the file. Let me make this bigger. It's located in users. Da, 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 da. This is the location, right? This is the map to the file, right? So when I say dot dash, it is interpreted by Python as this. Okay, the dot dash has the magic characteristic of transforming into that. Okay, now when I say dot dash and then I type assets after, then I say dot dash and then I say slash assets. Assets.
But do you have to put that at the end to name that variable? Like you have to put that at the end of the file.
Yeah. So for example, yeah.
Yeah.
So for example, that's what dot dash does, right?
Yeah.
Dot dash means this whole thing, right?
Right.
Right? And then assets means just assets, right? Because it's after that, right? And then if I want to get a specific file that's contained within that, I do that ball.png. So I'm saying the file called ball.png inside of the assets folder, which is inside the Python game class, which is inside of GitHub, which is inside of documents, which is in OneDrive, which is inside of right? All of that is stored magically in this, like, or I say magically, but it's interpreted as that.
Yeah.
Okay. So when I run this command here, it basically turns this dot dash into c dot da, 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 with slash assets, and then at the end it adds ball.png.
Yeah.
So that gives me and then Python, because now it has found the file on that location, then it uses this other method to load it, which basically like Python like eats the picture, turns it into binary, so we can use it for our own reasons, right? And then it and then it's usable as an image here. C'est la vie. Okay, so that is that, right? Yeah. So there I say like basically what we can do here is basically we run the thing, the ball, and the ball is there, and that's after it was loaded. So images like as I was saying, like bitmaps, like what is a bitmap? Oh, is the as I explained to you too, because you know about like the LEDs, right?
Yeah.
So like what is an image? It is a map of what LEDs need to turn to a specific color to make the image. That's what the image is. It's a bunch of numbers saying in this locate is a matrix. It's a matrix. Is a each each of the entries within a list have two other entries which signify an X and Y value, right? So it's a list that tells you what a square looks like, and that square has some color values,
Yeah.
right?
So like with this method of algorithms, is it possible for me to what if I like take a bunch of LEDs, right? And I want to like make like shapes and like words even?
You can even do better than
Like
that. So, for example, let me show you this one.
that'd be possible.
No, you could do it with programming.
Right.
But let me show you how crazy. Like, and maybe you've seen it. So, like, it is. fan uh, fan with LEDs that's made for is it this one? Yeah.
Wait, what? What the- Wait, what?
So take a look at that. So that is done through programming.
That's
Okay.
fucking insane.
So, but and I can explain to you how all that happens
Yeah.
because the spinning of the blades, right? The spinning of the blades give you the frequency of how much you are spinning, right?
That's
And then when you turn the things on and off, that is like what the program tells the fan to do,
right.
right? And what you display there is just a storage value of bit values, as I told you, right? So all of that is done through that.
Dude, people are literally lying. There's no one to listen
What you say, sir?
from like scratch. Yeah, how would you make that from scratch? It's crazy.
I don't know what to do, but I'm telling you, right? So, for example, okay, so you need to have this like I'm telling you what the data looks like, right? You have a description that is based in numbers, right? A description that is basically like saying, okay, I can show that real quick because I think this is not.
But I was thinking more like on a breadboard, not like not like
Oh, on I can. The thing is that the thing is that you do need to like it is super important to like on a breadboard. Okay, I'll tell you. Okay, so please note that there's some marker. Okay, yeah. So you do need to think that the breadboard part, it is highly connected. Like before, like if you want to do that, you need to before you even think about doing the breadboard, you need to think about how the program is going to handle that.
yeah.
Maybe some people would say the opposite, but whatever. So, I mean, could be both ways. But let's say that you have a program, right, that has in the data, right? Can this show? This? No. Hold on. Can I use black? Black's better. Please tell me this works. Okay. You have you have a picture that you want to represent, right? Yeah. This picture split into small squares, right? And like if it was like that battle like a battleship game, you name each of the squares.
Yeah. Isn't this like a 2D array?
This a 2D array or a matrix? Yes.
But yeah, because like I remember I was talking to Alfonso, right? Because I also had an idea of like kind of like a I don't know like a chess engine and like from scratch, right?
Yeah.
And
Yeah, you would do something
you
like
would
this.
do something like that. So you
Ten
told me,
times.
I'm like that makes sense. That literally looks like a chessboard.
Yeah.
Yeah.
And
Wait,
but then
have you seen the chess pods? How good they are? Like, have you ever gotten to
the
that? Like,
that
that's
yeah,
really
that's a
cool.
lot of that is very cool. But
Yeah.
that's like for example, to even understand why they are so complex, you need to understand that like the range of possibilities that they can handle,
Yeah.
right? And that they're like, I mean, they're not infinite, but it's like an ungodly high number.
No,
Like,
because usually you tell like the bots what openings to play or whatever, and then
I mean, yeah,
they run like a theory, and then they do whatever. Like
that would be
I
a
like chess, and I watch a lot of chess, so like that's what I understood from like
that's good.
yeah
Okay, well, no, but that is so. For example, that is the modern approach that uses like neural networks. Back in the day, they would program what to respond depending on the opening.
yeah
So like they would say like okay, they would have like basically like simple if then statements
yeah
that like would take like a long time to program, but basically saying like if like this guy moves this guy here, then you move this guy here. Like simple as right now it's like now it's like like a black box of like probability
yeah
mountains that like stack on top of each other, right? But But let me explain it first because we're getting derailed. Okay.
Yeah.
But let's think about okay the image. Okay. So how do you represent this image on like the RGB thing? Is that look? How can I represent this? I can represent it by doing like
Each one's an LED.
yes. So now that's why you need to keep track of them, keep track of where you place the LEDs,
Yeah.
like physically, so then you can like program them to do those designs that you want. Remember that I made the that like thing that like goes up and down on the. I don't know if you saw it.
Actually,
I made basically an LED like show that basically like it
is
was
this the one that says robotics club over and over?
no, not that. That follows the same thing.
Yeah.
But for example, I did like a simple one on a breadboard,
Right.
right? I just put like lights on top of each other, like on rows, right? And I would make like a light like go up and down.
Oh wait, no,
Yeah, that was me.
the one in Richard's office.
No, not that one is more complex than the one.
Oh.
The one I did in like an afternoon,
Yeah.
just to show people what it's all about. But I mean, it's the same thing though.
Yeah.
It's basically like that one is a bit has a bit more circuitry to it, but the principle is the same. Okay, you need to know where you're putting the lights physically, otherwise you will like physically, and then how to map them into the computer. Okay, so okay, my example it was something basically like this. Still a 2D array. So this is 0, this was 1, 0, 1, 2, 3, 4, 5, 6. I think it was something like that.
Yeah.
So basically, I would have like this light, this row was, this column was column 0, this was column 1, and each of them has this. Now, how do I represent that in an array? Same way. Look, remember this, the good old array
Yeah.
with two different values, right? So this one, which is this is 0, comma 0, 1,
Oh yeah, yeah.
right?
Like X
This
Y kind of.
exactly right. This is 0, comma no, this is 1, comma 0, 1, comma 0, and so on. And then for the next one, for the next row will be 1, comma uh 0, 1, comma 0, and then 1, comma 1, 1, comma 1, and so on, right? So that's how you can represent it in plain writing, right? And then this is just the mapping of where each of the lights is. So for example, then I would have to map this into like the the port of each of the lights.
You have to do it individually, like.
Yeah.
Oh shoot, is there no better way to do it? Like other like individually? Like you know what I mean? Like it has to be individual. Like if you want to like write something out,
Yeah.
it has to be individual.
Yeah.
Okay.
I mean there is like so so, for example, how my understanding of electrical is not the best, but I understand that, for example, for each row of the tesseract cube, right?
Yeah.
It's a cube. It's a I'll draw it out.
Wait, but is that thing in the lab?
Yeah,
I've never seen it.
the blue cube. Have you not seen the blue cube?
No, I've never seen it.
Oh, I'll show. But I mean, is the
I've only seen the cube that's in Richard's.
that cube? That's the one I'm talking about. Okay.
Wait, that one?
Yeah.
You made that one, right?
I didn't make it, but I know how they made it.
Oh, okay.
Okay. So from what I understand of this cube, okay,
Yeah.
so you see it has the lights there and it has the lights on the inside, right?
Yeah.
So basically you do the same data structure, right? But the way that these things are, so basically in here, there's like some circuitry, right?
Yeah.
And whatever value you pass to the circuitry, like it has like a waveform, right? Whatever that waveform looks like, it tells which one of these lights needs to turn on or off.
Right.
Okay, so it's still the same, but still you have to know exactly where each light is. There's no escaping that.
Isn't there a way to like if you want to do like some patterns or whatever, couldn't you just like
But
add or subtract to your the array? Like you know what I mean? Like
well,
subtract,
yes,
like
yeah, no. That's how you end up doing the patterns
yeah.
by adding or subtracting to the array. But before you even get into that, you need to build the thing and map each of them precisely. Because if they're not mapped precisely, then you're not gonna get anything.
Right.
So, and that is also just important to say that your computer has like uh, a 1,800, a thousand eight, 1,920 by 1,080 of these guys in front of you right now,
Right.
and they are all mapped. And that's times all of these things. That just tells you what industrial output does to the world. You see, like this complex purpose is like cake to us. Like we
Yeah.
make it like you see how many screens are in front of you. Like all this process needs to be done for each of these computers. A circuit is built in an industrial manner, and that's how we have so many of them,
Right.
right?
Yeah.
But there's no escaping that. And I'm building the driver, like that's what I'm saying. So
So it's
this
gonna
is
be
the,
like a really long code, pretty much. Like
yeah,
that's what you're saying. That's gonna be like a long code.
it's basically be like the light,
Right.
like this light maps into this part of the waveform.
Yeah.
So like if you have a wave, this part of the light, and I might be saying like something dumb right now, but well, if I understand it, is that basically the each of the lights on this row map into like this part of the waveform of, from this part of the circuitry.
I'm not too sure about.
That you will have to find out if you want to do like electrical engineer. So
Yeah.
yeah, so that's that.
I mean, I would assume so, but like each LED has like its own wave, you know?
Each LED has yes, each no not its own wave, but each LED has is mapped to a specific thing on a circuit.
Yeah.
That's as much as I can tell you. For for other stuff, watch the news.
Right. The
Okay.
news.
Yeah. All right. So we talk about what the PNG is.
Yeah.
Say, listening to that cool discussion.
Yeah,
Yeah.
we definitely went off track.
No, no. I mean, it's part of the thing.
No, yeah.
So display image.
Like,
See how to navigate GitHub folder. See how to navigate to the GitHub folder. You just call it ball. So let me see. Oh, I already showed you that to navigate to the GitHub folder, right? So
by the way, the
yeah.
the screen's not on.
Oh, my bad. There you go. So how to navigate to the GitHub folder, right? So I mean, how I do it. I mean, if you, I forget what it is that you
It's
can find.
usually user, no?
Yeah, users. I mean, depends. But no, I won't say depend. Yeah, most of the stuff that you're gonna use is gonna be users. Your use, your user. Actually, no. In this case, I think actually no. Users. Then in here you go to OneDrive. OneDrive. Then I go to Documents. It's always on Documents
Right.
by default. GitHub. And all my stuff is here. So GitHub, and then I go to my class assets, and there's the ball, right? So if I want to save something, so ball.png, I will just go here, grab this. It's probably not going to be exactly what I want, but save as. And then I navigate to the ball, right? I navigate, so pictures, I don't want pictures. I want to go to documents, GitHub, and Python 2D game class, and assets. I change it to something nice. That's important. Balls, not balls. Ball.png. And that would be what I would do, right?
Yeah.
Cool stuff. All right. So, previous system navigation. Yeah, I already explained that. Find the image method. Okay, so for example, like here, I did this thing to find the image very fast. So you want to check it out. So here, find that image. This is how you load an image. So you have load. Oh, cool. You have save too. So we could go over like some of the stuff here if you want. But like, for example, save would create a file, right? Like you would save an image. So if you want to take a screenshot of your
Oh,
game,
draw like
yeah, you could draw something and then save it. Yeah, you could do a bunch of other stuff. Like if you want to make paint,
yeah. I saw you can make paint. I
yeah, if you want. I mean, if you want to do that, yeah, for sure. So, for example, yeah, you have all the here's the description of all the things that a method does, right? Cool stuff. So, create a folder of assets, explain that, display the image. Yeah, I did that. I don't want to skip anything because I remember this all being like important stuff, but okay, that looks Good. Okay, so move assets. So here's where we start actually finally getting into doing the cool stuff. So how the stuff moves, and here we start going into stuff that is more for control theory, control systems, and all that, which is pretty cool. But so let's see, what did I write about? So we scale the image, right? So we have the scale, we scale the image here, although I end up not using this for other reasons, but we'll talk about that later. But
Yeah,
so
kind
for
of messes up the image sometimes.
depends, yeah, no, depends. You can probably do like a simple math
Yeah.
equation here to make it work. So I'll find that out a bit later, probably, but yeah. So image, we load the image, then so look at what I do here too. Keep pay attention to this part.
Yeah.
Is that I do pi image load. So I load the image, right? This is the binary of the image as is, right? Then I override it. I override it, right? So I created it and I didn't save it. I just overrid it and then I put it in the same memory spot that I was using for the previous image. I override that and I use my scaled image. Okay, scale it by like this factor. So yeah, and that creates something.
Yeah.
Okay.
Make it like a certain size, right? Make
Yeah.
it a certain size, yeah.
Now, one thing, keep track of this. Okay, this is very very important. Okay,
Yeah.
why did I put the x and y values outside of the loop? Why did I declare them outside of the loop?
Because now it's just gonna stay there in the exact same spot, no? Because it's a loop.
Yes, you're correct.
Yeah.
But what is the reason of that?
I think it would break the program pretty much. Like
It won't break the program, but you got to think about what you're telling the computer to do. So when I say x is equal to 500, right? What am I saying?
it's on the x-axis. It's going. If I remember correctly, it's going like to the right.
But I'm not saying that right now. I'm not saying that right now. We got to think about like on steps, right?
Right.
Okay, so if I say x equal to 500, what have I said?
Puts it on the 500, like pretty much like 500 pixel.
Yes.
Like pretty much like it's
Wait,
like
wait, wait, wait. It doesn't put anything anywhere at the
yeah.
moment. I just have a variable x, right? I have a little box that I have named x, and I have stored the number 500 inside of it, right? So this at the moment does nothing. Okay, the x does nothing. It's just where you're saying that there's a variable x, and this variable has been assigned the value of 500. Okay,
Oh, you mean like technically speaking?
yeah, no,
It's
we're talking technically speaking right now
like
because
it's
we want to
yeah.
find out why is it that I have done it outside of the loop. Because if you truly understand why, then you will be. This might seem too granular.
I know why.
Okay, go ahead.
It serves as a global variable. Like pretty much, no? Like it's a variable you can instead of like straight up writing out like the integer, you just write a variable. Like you know what I mean?
Yes, yes, but okay. So the reason for it is that we need to have a storage device
Yeah.
that is not subject to the loop.
Yeah.
Okay, so think about what would happen. Okay, if I declare it, what would happen if you said it right? What would happen if I declare this inside of the loop? What would happen?
Um, it would just stay in the same spot.
Yes,
Like
correct.
because
But why?
it's in the loop. Because it's inside the loop, and by just saying that, it's just gonna stay there. Like even though the loop is running, it's gonna stay there. No, because like
Yes,
you already set like a position for the
correct.
yeah
I think you're correct. You have the right idea, but
yeah
you just have to word it in a specific way to make it because you want to convey a specific thing. Okay, the thing that I want you to convey when you say this, right, is that at the beginning of the loop itself, okay, and loop means that it's going to repeat.
Yeah.
You're setting a specific value to the x.
Yeah.
So you're saying x is equal to 500. Okay, so if 500 means a position within the x-axis, right? If you say 500, like every time you're saying like position equal to 500, it's just 500, 500, 500 every time because you're setting it to 500, right? If I do 500, or I say the current x position, right, plus something, then I'm saying whatever the x position is now. That's the reason we use the variable, because
Yeah.
the variable can be mutated, right? We are changing the value
You
of
can
what the
add and subtract.
add, subtract, do many different things, right?
Oh yeah, yeah.
Over the course of the loop, right? So during the loop, as you can see here, I am doing x plus one. So
Yeah.
x is equal to x plus one, right? So what I do here, right, is you could say that the value of the variable is stored up here, right?
Yeah.
And this holds this value and also holds the value if it changes, right? Because as soon as this loop starts running, that value is no longer 500 because I'm telling it to be 500 plus 1,
Yeah.
right? And then the loop happens again. And if I were to set it to 500, right, it would basically set to 500 again. It would delete the progress per se that we did, right? It would overwrite that progress that we did and it would revert it back to 500, right? And then it would run the plus one again. And then we would only see the 500, like the thing on the same spot, because we're overriding the progress that we did to keep that progress of x plus 1 plus 2, well, x plus 1 and then x plus 1 plus 1, x plus 2 in like the time scale, right? We need to keep track of our position variables outside of the scope of the loop, right? Because otherwise we're just like resetting them every time,
Yeah.
right? So now if I run this, if I start moving,
Yeah.
it goes up, right? The little house goes up.
Yeah.
Yeah.
Flying house.
Yeah. So, and if I were to put it down here, right, it would just do that, right?
Yeah.
So keep that in mind, okay? Keep that in mind that the reason that, because this will not be done in the same manner later. The concept of this, right? And I have to stop now, but the concept that I convey here, right, is that the variables or that need to be like operated in one way or another need to be stored in a different layer than the loop,
Yeah.
okay? Because as we discussed, right, the layers are important, right? The layers mean, so yeah, the layers saying that this code operates by itself, and this code, you can say that the code that is on a different layer, and in Python you just do it by looking at the difference in spaces here. You can say that all this code, right, all this code over here is not affected by what will happen here, or like it's not directly affected. Well, actually no, it's the other way around, my bad. That all this code here, right, all this code here, right, is not affected by what happened here. Okay, the code inside here can affect what happened on the outside. Yeah. Okay, my bad on that one. But okay, yeah. So that's it for that. So that's the review up until what, three, to chapter three of my little syllabus. So if you want, next time I'll go over the other stuff too. So for example, like
Yeah.
I talk about function. I did this whole thing.
Functions.
Yeah, like how to like express it and all that.
Yeah.
I do want to make this even better, but for that I should plug in the mic better and all that. So I want to make this like super concise, super fast. So
Yeah.
it's like a fun thing to like just like skim through if you want to come into the class, you know? Okay.